For section 1.3, the power of algebra, we're dealing with both factoring and rationalizing as well as simplification. So we're going to start with talking about factoring. So when we talk about factoring, it depends on what we're looking at. So, we could have, quadratics. Quadratics can be kind of tricky. This is like our first sort of thing that we're looking at. So there's no rule in particular, but if we look at something like this, x minus a times x minus b, where does that come from? What does it create? Well, this creates x squared minus ax minus bx plus ab. So what does this really tell us about anything? Well, what we see here, and we kind of did this a little bit in pre-calculus, is that the product of the roots can be at the end, and the opposite of the sum of the roots is going to be in the middle. Now this can affect things a little differently, but it's a hard rule to kind of understand, but you kind of have to play with it and understand where the numbers are coming from. Now, if there's a constant up front, that could change things a little bit and make it a little more fun for you. But realize the point of factoring is to try to go from a statement, that is like this and trying to go back. That's what factoring is. Right? We're trying to find the factors, the multiplication parts that make that work. Now there is a special rule called the difference of squares. This one comes up a lot, and that says that if you have like x squared minus a squared, you're going to end up with x minus a and x plus a. So if you have a parabola without a regular x term, without that, then you can factor it very fast. You just have to figure out what the square root of the second part is and then break it up. This is going to come up a lot, so make sure we know what that is. So that's that for quadratics. There's not really anything special about it. The difference of squares is unique, and that comes up a lot, but the other version is more difficult to deal with. So when we talk about cubic functions, so cubic functions, there's a few different things. There's the sum of cubes. So the sum of cubes works like this. If you have, let's say, x cubed plus a cubed, that's going to look like x plus a times x squared and then minus ax plus a squared. So always in this situation, it's going to work out like that. It's pretty simple. There's not a lot of numbers going on. You basically just figure out what the cube root of each of these parts is, and then those go where you need to go. There's also the difference. Oops, won't let me pick my pen. The difference of cubes. So if I said I have x cubed and I'm going to subtract a cubed from it, I can break that into x minus a times x squared plus ax plus a squared. So notice that with the sum of cubes, the plus sign comes first, and in the difference of cubes, the minus sign comes first. So that's it. So they both have one minus sign. These rules are kind of quirky. They show up sometimes, but it's very good to know because it can be very helpful to figure out certain types of problems. So just really try to read what kind of graph is this. Now, cubic functions can have x squares and all that kind of stuff in it. That becomes really hard to factor. Cubes can only factor in certain situations, either the sum of cubes, the difference of cubes, or this last part. It is possible that you can factor by grouping. So let me show you what I'm speaking of. So a squared plus 1 times a minus 2. So let's say that is our our factors. If we were to multiply this all out, we're going to get a cubed minus 2a squared plus a minus 2. So what you have to figure out automatically is there a ratio going on? Is there a ratio that it connects the two things? So we look at our first two terms and our last two terms. So we've got a cubed minus 2a squared, and we've got a minus 2. So we've got a 1 to a negative 2 and a 1 to a negative 2. And so that kind of tells us, and we can kind of say, okay, well, obviously, you know, there's an a to a minus 2 sort of part there. Now, if we can factor that out and figure out, oh, well, if we take an a minus 2 away from this, we get a squared. This is a much more complicated type of factoring. I'm sure you all will have plenty of questions about it. It's a lot easier to explain in person and by example, but if you have a long string, 4 parts of a cubic equation, so like this right here, the only way that we can factor this is if we find something common. Okay, don't you just hate phone calls? I do. Alright, so let's keep going. So now we're going to talk about fractions, our good old buddy fractions. So remember our rule. Let's say we have pick the pen. A over B plus C over D equals A D plus B C over B D. Now, I always think about the ninja method. So we go down, and then we go whatever symbol is in the middle. So we do that, and then we go up, and then we go across. So that's our ninja method, right? Just like slice. I think of it as like slice down, slice up, slice over. So that is how you add fractions. And so we will talk about how that works later, but this is the basic need to know done part. And very, very lastly, wait, where's my mouse? This is not fun. Okay, so the last part, we're going to talk about rationalizing. So rationalizing means that we're taking square roots out of a denominator. Okay, so there's a couple of different ways that can happen. So let's say, for instance, we have 1 over the square root of a. So we don't like that. So to rationalize, we would multiply by the square root of a over the square root of a, resulting in the square root of a over a, because square root of a times the square root of a makes regular a. Perfect. Okay, so no longer are we dividing by some square root. So that's the purpose. If we just have a single term, one term, this is simple. Now what happens if it's not a single term? Let's say we have 1 over the square root of a minus 2. Oh no, right? What do we do now? Well, if we try to multiply by the square root of a, it's not going to work, right? We're going to end up messing things up even worse, because the square root of a will have to attach to the negative 2 as well. What we have to do is go back to the beginning and think to ourselves, how do I take 2 terms and only get 2 terms back, and I don't have any square roots or anything weird? Well, we use this difference of squares idea. So what we can do is see how both terms are squared. There are no square roots. If there's a square root at the beginning, we can get rid of it. So what we have to do is use what I call the evil twin method, by multiplying by the denominator's evil twin. Follow me back. So here's our denominator, 1 over the square root of a minus 2. I will counter with its evil twin, the square root of a plus 2. Just switching the sign. The other terms stay the same. So the top is going to get the square root of a plus 2. Now, because of the difference of squares, I know that these multiply to make a, these multiply to make negative 4. There are no middle terms, they're going to cancel, and so the top is just 1 times the square root of 2. Now, the top doesn't matter. The top can have square roots. No big deal. Bottom cannot. So that's the last real part of this. What we want to make sure that we know when we add, we'll make sure that we know, and maybe let me go back and add one little thing to fractions, that if we are to, let's say, have A over B over C over D, how do we divide fractions? Right? Well, instead of thinking of it as dividing fractions, the easiest thing to think about is multiplying. Well, dividing and multiplying are just kind of, they're inverses of each other. So what we can do is, instead of dividing by C over D, I can think of this as multiplying by D over C. I flip the denominator and multiply across. Makes it so much simpler because I just tack these on together. That's really the only stuff we need to know. Now, this is all algebra tricks to make your life easier. You may say, you know, kill me now, this looks awful, I hate my life. But, you know, that's, it's not as bad as you think. It actually is kind of fun to see something crazy turn into something nice and neat. So, just know these rules, we will keep working with them, no need to master them immediately. Just realize that there are rules that govern this stuff, and always try and research whatever you can.